Good morning, students. So, last class we were discussing about the common characteristics of acids and bases. So, what are the common characteristics that acids and bases have? So, we have studied about dilute acid, concentrated acid, isn't it? So, all acids they are giving H plus ion in their aqueous solutions, and bases are the substances they give OH minus ion in their aqueous solutions, isn't it? So, so what is happening in the case of an acid and base? So, when they are present in their aqueous solutions. So, what is happening? What happens to an acid or base in their aqueous solutions? So, for that you take two test tubes. So, in one test tube you take sodium chloride, 1 gram of sodium chloride, and in another test tube you take sulfuric acid, H2SO4. Then you add this sulfuric acid into sodium chloride. So, when you add sulfuric acid into sodium chloride, after that you close the test tube with a rubber cork. And also fix a delivery tube into this test tube through this cork. And you also carry two litmus paper, that is one is dry blue litmus paper and other one is moist or wet blue litmus paper. So, when you add sulfuric acid into sodium chloride, some gases are evolving, and that gas is what? It is HCl gas, that is hydrogen chloride gas. Hydrogen chloride gas is evolving from this mixture, and then when it is passing through this delivery tube, you place a dry blue litmus paper near the mouth of the delivery tube, and you can observe any changes happening in this dry blue litmus paper. The same experiment is repeated with instead of dry blue litmus paper you place a moist blue litmus paper. So, when you place moist blue litmus paper, what changes is happening on this litmus paper, blue litmus paper? Is there any color change? You can see that in the case of dry blue litmus paper, there is no color change in the color of the litmus paper, it remains the same. But when you place moist blue litmus paper, you can see that the moist blue litmus paper changes into red color. So, what is the reason for that? So, here we have taken blue litmus paper, but one is dry and other one is wet. So, in the case of wet or moist blue litmus paper, water is there. So, this water, because of the presence of water molecules ionizes hydrogen chloride gas into H plus and Cl minus ion. So, only in presence of water or aqueous solutions, acids show their acidic behavior. In presence of aqueous solutions, and that is why you can't see any color change in the case of dry blue litmus paper. There is no change in their color. Why? Because there is no water. So, we have already studied this, that is HCl is ionized to give H plus Cl minus ion, and these H plus ions, this ionization is happening only in presence of water. Is happening, and water, we know this H plus will combine with the water molecule, because this is not having independent exchange, they readily combines with the water molecule and it forms H3O plus ion, that is hydronium ion. So, that is why this type of ionization is happening only in presence of water. So, aqueous solution give acidic behavior, only in presence of aqueous solutions they show acidic behavior, but if it is dry condition they will not ionize, that is why they will not give any color change in this litmus paper. Why? Because there is no ionization. So, ionization is occurring in presence of aqueous solutions, and that is happening same in the case of bases. In bases also that ionization is taking place in presence of water, and then if it is sodium hydroxide, how they are ionizing? It ionizes to give Na plus OH minus ion, Na plus and OH minus ions, and this ionization is taking place in presence of aqueous solutions. Okay, hope you understood. So, on wet blue litmus paper changes into red color, that is because of the presence of water molecule. So, water ionizes the HCl hydrogen chloride gas into H plus and Cl minus ions. Okay. Now, next we are discussing about, you might have heard about dilute acid, concentrated acid, dilute sulfuric acid, dilute hydrochloric acid, concentrated sulfuric acid, concentrated hydrochloric acid, etc. Isn't it? So, how we can dilute an acid? How can we dilute an acid? So, here when we dilute an acid, we have to add acid to water, not water to acid. We have to add acid to water through the sides of the container with constant stirring. Acid to water, not water to acid. Why? Because when you when we are taking some, if you take a test tube and you take some water in that test tube and you pour some concentrated sulfuric acid to the sides of the test tube, and then you can see that when you hold the test tube you feel hot. Why? Because it is an exothermic process. We have studied what is exothermic process, because the process in which along with the products it also produce what? Heat energy. That is called exothermic process. Any chemical reaction along with the products, they also produces or evolve some heat. That is called a exothermic process. The mixing of acid and water, it is also an exothermic process. It is highly exothermic process, and care should be taken while we are mixing an acid with water. So, you have to add acid to water, not water to acid. Okay. Why? Because see, when you take some water, and if you are adding concentrated acid through the sides of the beaker with constant stirring, if you take a glass rod, then with constant stirring you add acid slowly into this beaker. So, it will be diluted. So, at that time, while they are mixing, when they are mixing, at that time it produces some heat energy, and that heat energy is absorbed by the water molecule. Water can absorb the evolved heat, and that is because water is having specific heat capacity. They are having specific heat capacity is there, and that is why water can absorb that heat. But when you mix water to acid, for example, if you are taking acid here in the beaker and if you are adding water, at that time also heat is evolved or heat is produced, and that heat energy cannot be this acid cannot absorb that heat energy, and it is a highly exothermic process, and because of that heat energy may splash out this beaker. It may break the container and it may cause burns. So that is why care should be taken while mixing this acid and water, and you have to add acid to water, not water to acid. Okay. So while mixing, while mixing water to acid or base, what is happening to their concentration? So their concentration is reducing, or that is decreasing. So it becomes diluted. How it is diluted? That is, when we add water to acid to water, so that is called dilution of water. So the concentration of H3O plus ion per unit volume decreases. When we add acid to water, the number of or the concentration of H3O plus ion or concentration of OH minus ion in the case of bases, it decreases per unit volume, isn't it? Per unit volume, the number of H3O plus ions or number of OH minus ion per unit volume. If you take a small amount or a unit volume, and in this unit volume, number of H3O plus ion decreases or number of OH minus ion decreases per unit volume if we dilute, if we are mixing with water, isn't it? So at that time the acid or base is said to be diluted. That is called a dilution. That process is called a dilution. So at the time of dilution, the number of H3O plus ion per unit volume decreases. At that time, the acid or base is said to be diluted. Okay. Now we move on to the next topic, that is pH scale. We are all taking mineral water, isn't it? So on the surface of this mineral water, you can see there are some data given. What are the ions present in that mineral water, isn't it? What are the different types of minerals? That is carbonate, then chloride, then many ions, that is fluoride ions, and then TDS, total dissolved solid, and you can also see pH value. So what is pH? So normally we can find out the concentration of a solution. You know what is a solution? A solution is made up of what? Solute and solvent. These things you have studied in your lower classes. Solute plus solvent gives what? Solution. So in order to find out the concentration of a solution, we are using a term, that is molarity, but here we are not discussing that. Molarity, it is represented by capital M. Molarity is the number of moles of solute, in 1 liter of the solution. That is called a molarity. Number of moles of solute, mole concept you have studied, moles of solute divided by volume of solution in liter. So that is the molarity, number of moles of solute dissolved in 1 liter of the solution. That is molarity. And the concentration of a solution is represented in square bracket. Concentration of solution is represented in square bracket. And the concentration, generally the concentration is represented in square bracket. But here in the case of acids or bases, that is acids, we can represent the strength of an acid or base by means of a that is H plus ion concentration. You know, the strength of an acid depends on the number of H plus ion present in that solution. So, if they give more H plus ion, that acid will be more acidic, isn't it? And so we can represent, so this is how can we read this one? This is concentration of H plus ion, concentration of H plus ion. If the concentration of H plus ion is more, it means it is more acidic. It is the strength of an acid is more. That is its meaning. So, H plus ion concentration. Here a scientist, that is Sorensen, his name is Sorensen. Sorensen, he developed this scale, that is pH scale. pH, here P stands for potence of hydrogen ion concentration, H plus ion concentration, that is pH. Potence, it is a Danish word. It is a Danish word. It means power of H plus ion concentration, power of H plus ion concentration. And he derived an equation, that is pH is equal to negative logarithm of H plus ion concentration. We can find out the strength of an acid by this equation, that is pH value. pH is equal to negative logarithm of H plus ion concentration, negative logarithm of H plus ion concentration. And it is found that the value of pH, if the value of pH, we can find out the value, I will tell you, I will discuss how can we find out the value of an acid. So, if the value of pH is less than 7, if it is less than 7, if the value of pH is less than 7, then that substance is acidic. That substance is acidic in nature. If the value of pH is greater than 7, then it is basic in nature. And if the value of pH is equal to 7, then that is neutral. So, for pure water, the value of pH is 7. So, neutral substances, the value of pH is 7. For basic substance, the value of pH is greater than 7, and that is up to 14, that is 7 to 14. The value of pH is, if the value of pH is greater than 7, that is less than 14, greater than 7, that is basic in nature. And if the value of is 0 to 6.9 or 0 to 7, if it is 7, it is neutral. Less than 7, that is 0 to less than 7, that is acidic in nature. That is acidic in nature. So, that is for acidic, basic and neutral substances. Now let us see how can we find out the value of pH. So, this is the equation to find out the value of pH, that is pH is equal to negative logarithm of H plus ion concentration, negative logarithm of H plus ion concentration, that is pH is equal to negative logarithm of H plus ion concentration. Now, let us, for example, if there is an acid whose concentration is given as 10 raised to minus 3 molar concentration. If there is an acid, if its concentration is 10 raised to minus 3 molar concentration. 10 raised to minus 3, what is 10 raised to minus 3? That is 1 by 1000 is called 10 raised to minus 3. If its concentration is given in molar, that is 10 raised to minus 3 molar concentration, then find out its pH value. Find out its pH value. That is the question. So, how can we find that? Is pH is equal to negative logarithm of H plus ion concentration. Here the H plus ion concentration is given in molar, that is 10 raised to minus 3 molar concentration. Then how can we find out the value of pH? So, here we can substitute this value pH is equal to negative logarithm of H plus ion concentration is given as 10 raised to minus 3, 10 power minus 3, 10 power minus 3. And in mathematics there is an equation that is log x raised to m is equal to m log x. Log x raised to m is equal to m log x, m log x. And also one more that is log 10, the value of log 10 is equal to 1. The value of log 10 is equal to 1. So, log x raised to m is equal to m log x. If log x raised to n, then that is n log x. If log x raised to y, then y log x. Okay. Then the value of log 10 is 1. Then how can we find out this value? So, negative logarithm of 10 raised to minus 3. So, in place of x it is 10 and in place of m that is minus 3, isn't it? Then how can we find out? That is this is log x raised to m. So, m log 10 in that way. So, already one minus is there. So, minus here minus 3 into minus log power 10, sorry log 10, that is m minus 3 log 10, log x raised to m, that is m log x. Here in place of m it is minus 3. So, minus 3, already one minus is there. So, minus 3 into minus log 10, that is x, the value of x is here 10. So, minus 3 into minus 3 log 10, and we know the value of log 10 is 1. So, minus 3 into minus 1, it means 3. So, the pH value of an acid whose value is 10 raised to minus 3 molar, it is what? pH value is 3. If it is 10 raised to minus 5, then the pH value is 5. If it is 10 raised to minus 8, then its value is 8. If it is minus 7, it is 7. So, in this way we can find out the value of pH. Okay. So, this is about pH scale. So, what is pH scale? It is a scale used for measuring the concentration of H plus ion in a particular solution. In a particular solution, we can find out the value of H plus ion concentration. The concentration of H plus ion, it is a scale used for measuring the concentration of hydrogen ion in a particular solution. That is pH scale. Okay. So, that's all about pH scale and the applications of pH in our daily life that we will discuss in the next class. Okay. Okay, have a nice day. Thank you.